Kinematics question 9, a projectiles problem. At time t equals 0, a particle is projected from a fixed point O on the ground with speed u at an angle of theta degrees to the horizontal. So the horizontal velocity will be u cos theta, the vertical velocity will be u sin theta. It moves freely under gravity and passes through the point A when t equals 4. As it passes through A, the particle is moving upwards at 20 degrees to the horizontal with speed 15 meters per second. We're asked to find the value of u and the value of theta. Let's start with the horizontal motion. Here, the horizontal velocity u cos theta will equal the horizontal component of the velocity at A, which is 15 cos 20. We consider the vertical motion. We'll use the formula v equals u plus at. The vertical velocity at A will be 15 sine 20. The vertical velocity at O is u sine theta, and the acceleration is minus g, so we have minus g times 4. We rearrange and we have u sine theta equals 15 sine 20 plus 4g. Dividing the first and second equation, we get tan theta equals 15 sine 20 plus 4g divided by 15 cos 20. We can calculate this to be 3.145, and we use tan to the minus 1 to see that theta is 72.4. At the point B on its path, the particle is moving downwards at 20 degrees to the horizontal with speed 15 meters per second. This will be the equivalent point on the trajectory at the same height as A. We're asked to find the time taken for the particle to move from A to B. We consider the vertical motion starting at A, and we're going to use S equals ut plus a half at squared. Now, we've considered the motion starting at A, so the displacement vertically at B will be 0. So we have 0 equals the vertical velocity at A, 15 sine 20 times t, minus a half the acceleration g, t squared. We solve this and we find that t can either be 0, which is the point when it's at A, or it could be 1.05, which is the time it takes to travel to B. The particle reaches the ground at the point C. We're asked to find the distance OC. So we can calculate the total time of travel. For the first part to A, it's 4 seconds, we're told that. Then, by symmetry, the last part from B to C will also be 4 seconds. So if we add in the time to go from A to B, we get a total time to travel from O to C of 9.05 seconds. Now, the horizontal velocity is the same all the way through, and it is 15 cos 20. So we multiply this horizontal velocity by the time 9.05 to get a distance for OC of 128 meters.